any time as far as I'm concerned. All right. My name is Greg Samples. I've been practicing macrobiotics for 35 years, since 1985. I've been teaching and counseling since 1988. It's been a wonderful journey, as most of you know, from macrobiotics. I studied at the KI in 1988 and came back to Knoxville, Tennessee, where I live, and began teaching at that point. If you want to contact me, you can do so through my website at gregsamples.com. There's articles on there, and there's also other information that's charts and so forth that you might find useful. I was asked today to talk about terrain theory, which is right in line with macrobiotics, because terrain theory means it's the opposite of what is known as germ theory. In the 19th century, there was a debate going on in the scientific community between Louis Pasteur, which we've all heard of, who is a proponent of what is now known as germ theory, which is what Western medicine is really based upon as far as communicable disease is concerned, and what is called terrain theory, which was promoted by Antoine Béchamp. Unfortunately, germ theory was the victor in that debate as far as the medical community goes. But as we know from our study in macrobiotics, which is quite familiar with terrain theory, the condition of your own internal environment, your body, is really what determines what illnesses you experience or what diseases you come in contact with. So today we'll talk about all microorganisms. This is what we're going to talk about. It applies to all microorganisms, but we'll focus especially on viruses, and the one that's really prominent today, of course, the coronavirus. Corona just means, it's a Latin word, it means crown. So it's a virus that enters our body through the top part of our body, the crown of our body, or our head. Microorganisms consist of viruses, bacteria, and fungi, and some others. But the overwhelmingly greater abundance of all these is viruses. In fact, viruses consist of, are more abundant than all other life forms on Earth. But they're very important to us. We couldn't have life without viruses. They help to regulate the ecosystems. They are important in species diversity and in evolution. So the idea that the virus is some kind of enemy of the human beings is not very logical, since we couldn't exist without them. The way that viruses enter the body is through contact, of course, but the important thing is what our body relates to it, or how our body responds to it when we come in contact with the virus. Now, how often do we come in contact with the virus? Well, in an average day for an average person, we actually come in contact with 380 trillion viruses. That doesn't include the 60 trillion bacteria that we come in contact with. So the idea that we can somehow avoid contact with viruses by our lifestyle or the things that we do in life is sort of ludicrous. The important thing is, which is mainly dependent on our internal condition. But of course, macrobiotics is the basis of how we do that. In macrobiotic philosophy, we divide or separate diseases into two grand divisions. One, of course, is called degenerative diseases, which is cancer, heart disease, diabetes, and so forth. It's called diseases of adjustment. Diseases of adjustment are anything that we would come in contact with in terms of a virus or a bacteria or so forth, in short, infectious diseases. So excuse me just a minute. So the response that we have to the virus is the most important aspect of what we do. So in terms of coronavirus, this is a virus that enters through our top, like I said, the top of our crown, the head. And the sorry, keep getting back up, just 380 trillion of them a day. The size of a virus is about 0.02 microns. That is so small that you could only see them through an electron microscope. So the pores of our skin are actually 250 to 500 microns. So a virus could easily enter our body just through the pores of our skin, but it will not do that because of what we have called our innate immune system. There's two types of immunity that we have. One is called innate, the other is called adaptive. The innate system basically responds to all types of viruses or all types of bacteria. As far as our skin goes, the pores of our skin are filled with sweat and other alkaline material. So unless we have a cut or an incision or something like that, a virus cannot get into our body through our skin, even though the pores are large enough for it to enter, because it would be destroyed in that alkaline environment. Viruses are sensitive to certain things. One of them is alkalinity. They do not function at all in an alkaline environment. They need an acid environment to function. So, hang on just a second, there we go. Okay, so the way that viruses do get into our body is through our mucous membranes. Through our nose and other parts of our body that are exposed, the genitals and so forth. Well, like I said before, the virus cannot survive or function in an alkaline environment. So if a virus, we come in contact with a virus through our mouth or our nose, you notice that you always notice it at first by getting a sore throat. You know, you don't notice it on your tongue or on your cheeks or so forth, because those are normally bathed in saliva, which is an alkaline fluid in our body. But you might get it in the back of your throat or in the nose. So as the body enters, our immune system starts to begin to function in response to that. The first thing it does is, if you have exposed to a virus, is it produces a mucus. Okay, the mucus is actually a part of the innate immune response to a virus, which is a part of defense. It's like the barrier that goes up to keep the virus from getting into the body. So that is a response from histamine in the body. Histamine is the hormone which stimulates the body to produce mucus. Of course, we can go to the drugstore and over the counter get an antihistamine, which we might want to do because it would make us feel better. It's having mucus in our mouth or nose or so forth is very uncomfortable. So we're motivated to get an antihistamine to stop that. But unfortunately, that antihistamine is actually stopping your immune system from doing its function, which is to produce mucus to block the virus from getting into the rest of your body. So, you know, even though an antihistamine might make us feel better temporarily, it's actually having the opposite effect we want to have for our immune system. Now, what determines whether or not you create mucus through it because of histamine production? When we take certain foods into our mouth, they are either digested in the mouth, which is grains and carbohydrates are digested in the mouth. Other types of food like protein is digested in the stomach. Fats are digested in the duodenum and the lower digestive tract. So it's the carbohydrates that are the main issue about being broken down and creating an acidic environment in the mouth or nose, which allows the virus to proliferate. So when we eat things like whole grains, those grains that we have to chew very well to begin the digestion, we mix them with saliva. The saliva is alkaline enough that it prevents that type of situation from happening because, once again, viruses don't survive well in an alkaline environment. But if we eat carbohydrates like flour products or simple sugars that are broken down immediately and are digested right in the mouth, then that creates an acidic environment which the viruses can then proliferate and enter our bodies. So that's why in macrobiotics, it's well-known fact that we prefer to eat whole grains in their whole form, such as brown rice, millet, barley, and so forth, rather than flour products like wheat, bread, or noodles and things like that. Of course, whole grain noodles or breads are much more functional than white and simple carbohydrates that have been broken down even more. But still, any kind of flour product, such as a whole wheat bread, that's going to create a situation where viruses can proliferate easily. So if you have a diet that is not going to be, have any flour products in it and dairy products as well, because dairy has lactose in it, which is digested in the mouth, and other simple sugar, then you're going to expose yourself to the possibility of contracting a virus. Now, once the virus gets through the mucous membranes in the mouth and the nose, they move on to the next part of the immune system. The second part of the immune system is developed, and that is our tonsils and adenoids. Tonsils and adenoids are in the back of the throat and back of the nose that are filled with lymphatic tissues. Their function is to attack and restrain any kind of virus that is in the arena, in the area. But of course, many of us, especially the older generation, have had our tonsils and adenoids removed, one or both. This was an idea back in the 50s where, if you had a diseased organ that kept getting diseased, you took it out. You had surgery to have it removed. So anybody that's had their tonsils taken out is automatically immune deficient, because that's the organ that's your first line of defense against any organism that's attacking you through your mouth or nose. So those of you that still have your tonsils, congratulations, you're one of the few if you're over 50 years old. Then if you get through, if the virus is able to get past the tonsils and adenoids, then the next thing that takes over in the defense is the blood itself. The blood has certain propensities to it, such as interferon, which is a type of cytokine, which it alerts the rest of the body to that there's a problem. It's like, you can think of it as Paul Revere, somebody who's alerting people that the body is being invaded, and making sure that the entire body is ready on alert to deal with this invader that's coming in. Interferon was actually many years ago was thought to be a promising potential for cancer treatment as an immune response to cancer. Unfortunately, or fortunately, what they discovered was that artificial interferon, or taken from another person, the body tended to reject it. The immune system would tend to reject it. Well, fortunately, there's an element in shiitake mushrooms that, of course, we use in macrobiotics all the time, which stimulates the production of interferon in our bodies. That's why when if you put dried shiitake mushrooms into your soups or dishes and so forth, that's going to stimulate the production of interferon in your blood and help your immune system. So from a macrobiotic standpoint, that's very cute, very nice. That's what we call the innate immune system. And that responds to any type of attack by any virus or any bacteria. And it doesn't matter what it is, the response is the same. The next response is called the adaptive immune system. The adaptive immune system responds to specific viruses or bacteria. Your body has to learn how to deal with these, and it does that by producing antibodies. The antibodies are actually entities that attack specific viruses in the blood or in the body, in the intercellular material, intercellular fluid. So this is done by the body identifying the invader and then creating T cells or B cells, which then produce these antibodies to attack it. Now, the T cells have two types of responses. One is called a Th1 response, and the other is called a Th2 response. The Th2 response is just the antibodies which attack the viruses while they're circulating in your body. But that's only half the problem. The other problem is what the virus does. A virus is basically just genetic material that is wrapped in a protein. It cannot reproduce itself. What it has to do is it has to enter your cell and then use your DNA inside the cell to reproduce itself. Makes multiple copies of itself. When it makes so many, then it bursts out of the cell, which kills the cell. And then those multiple copies can become available to enter other cells and reproduce. And so that's what infection is really about. It's about viruses becoming so prevalent in your body due to this reproduction cycle that they start to do harm and you start to get symptoms from it. So the immune system has two responses. One is the antibodies that kills the viruses while they're circulating in the blood or in the intercellular fluid. And the other is what we call killer cells, which actually attacks and kills cells that have been infected by this viruses. Vaccines, however, are lacking in the Th1 response. The Th2 response is what the vaccine produces. It will attack via antibodies that are produced any viruses that are floating around in the intercellular fluid, but it will not attack the cells that have been invaded by the virus. So any virus that gets past the antibody defense and into the cells can reproduce and produce all again. So that's why that's why vaccines are often not lifetime immunity like a natural immunity would be. They're only partial immunity or short-term immunity, so that you have to go get a booster shot or something like that because it didn't get the Th1 response properly done. So in this particular virus, we may have noted, you've probably seen news reports that the older population is more at risk than the younger population. And there's a reason for that. The thymus is a gland that is as large as it's going to be on the day we're born. From that point on, it gets smaller and smaller and smaller. And as we age, get very old, it can be almost nothing. It can be just nothing but scar tissue left. What it does, one thing it does is produce human growth hormone. It stops doing that when we're about 17 or 18 years old. But the other thing it does is it takes stem cells from the bone marrow and produces T cells, which are part of our immune system. Now, I don't know, this might be an anthropomorphism giving human traits to or thinking to cells, but it acts as if if you're not going to use something, the body stops producing it. So in most of our life, especially in our young life, we come in contact with viruses throughout the environment that we're living in. By the time we're 70, 80, 90 years old, it can be assumed that we're not going to likely to be involved in finding another, coming in contact with a virus that we haven't already experienced some point in our life. So if we have experienced contact with the virus, then what happens is the T cells, which means thymus derived, have memory cells, and at any moment's notice, they can call up or reproduce antibodies which will respond to that virus. But if you come into contact with a virus that, when you're 80 years old, that you have never experienced before in your life, you have to make, new antibodies for that virus right on the spot. And if your thymus is not functioning at that point in time, then you don't have the ability to make T cells or antibodies to respond to that virus. So that's why if you're an older person, it's very important to keep your body entirely alkaline, so that because your thymus may not be functioning well enough to create antibodies to defend against the virus. But the nice part is for us that if we keep our bodies alkaline by an alkaline diet, then that never becomes an issue, because the viruses are not able to proliferate in an alkaline environment and get to the point where you even need the T cells at all. So that's why you can pretty much travel all over the world, and you can't find a macrobiotic person who has been practicing diligently that has succumbed to the coronavirus, because the immune system really never has to activate itself, because the virus is never able to take hold in the body. So once again, if you do have a situation where a virus, whether it be the coronavirus or some other virus, that is being actively invading your body and your body is not responding properly, then your lymphatic system becomes very active. The lymphatic cells are producing these white macrophages and antibodies and spreading throughout the body through the lymphatic system. But the lymphatic system does not have a pump to do that with, which is what like the heart does. The circulatory system has a heart that pumps blood through and circulates throughout your body. But the lymphatic system, although it can go down, gravity can take it down in your body, only exercise or movement will able to, through contraction of your muscles, will move the lymphatic system upward in your body. One of the things that's really good to do that with is one of these, like a little trampoline, because the movement of the trampoline with upward motion tends to move that lymphatic fluid throughout your body. So if you have a situation where you have a lot of T cells that are being produced and lymphatic material being produced, then you may get a swelling in these lymph nodes, which are in the neck and the groin and the armpits and so forth. If you have that, that means your body is really under attack, and you need to make sure you're getting on it right away, because at that point your body is really under strong attack. Another thing that happens is, by the way, the lymphatic system is basically salt water and other lymphatic material. So in other words, it's a very alkaline situation. Fever, when you get to a certain point, the body produces fever. And because one of the things that viruses can't survive well in and don't function well in is a hot environment. Heat will, extreme heat, like boiling water, will kill a virus. Cold puts them to sleep. Like if you put your food in your refrigerator, you don't kill the viruses that are in the food. You just kind of put them to sleep so that they don't continue on and damage your food. But if you take them out and leave them at room temperature, of course, then the viruses and bacteria and so forth will take care of them. heat inhibits the microbial activity and multiplication. Another organ that is sometimes removed that is very important to the lymphatic system is the appendix. It hasn't got to do so much with viruses that we would contact through our nose and mouth, but those that we ingest, especially this is more of viruses that are associated with meat. So if you don't have an appendix and you have animal food that has not been properly cooked, or even vegetable quality food that has not been properly prepared or eaten in a raw form that has not been cleaned and so forth, then the lymphatic system in the appendix is necessary to deal with that. So we have a situation where I'm going to use a military analysis here for your body, because when a virus comes into your body, it is under attack. Once again, we can't think of viruses as enemies because human life couldn't exist without them. But in a real sense, your body is using a defense mechanism militaristically to protect itself against viruses. So the antibodies you could think of as soldiers. An antibody will, like a soldier, will actually identify the enemy, know who the enemy is, and take that enemy out. That's what an antibody does. T killer cells, you can think of them as the Marines. They're going to go and attack a certain island or a certain place that's specifically been targeted, like a cell or something that is being attacked by the virus, and wipe that cell out completely. One we get into trouble is when those two situations, the killer cells, T killer cells, and the antibodies, when they're not doing their function properly, the third thing comes into and this is like the Air Force. The Air Force, it comes in and it's going to bomb a certain area, and it's going to kill the enemy, but it's going to kill a lot of innocent people too. What they call friendly fire or collateral damage. So cytokines, they will kill a virus, but they will also damage your cells that are near the virus. That's what they do. You can think of them as like the Air Force. So you may have heard the term when we talk about this coronavirus as a cytokine storm. This is what happens, and it's not unique to the coronavirus. This would happen with any virus, but it's just that the coronavirus, we haven't had a chance to develop immunity to it, natural immunity to it yet. So when you hear things talking about like the virus causes damage to your heart or damage to your lungs or things like this, it's not actually of course, if the virus is unchecked, yes, that would happen just by destroying the cells in those organs. But it's also the cytokine storm that your own body is doing to protect itself against those that is damaging those organs. So it's very important to stop that before you get to that point. Once again, there's two types of cytokines. There's one that's called pro-inflammatory, and another one is anti-inflammatory. The pro-inflammatory ones are the ones that do the damage. And once again, those shiitake mushrooms can be helpful in preventing that from happening. Let's see, one other thing. I don't want to miss anything. So that's how your immune system functions, but it's like a house. It's been built probably for your whole life. It's there, but it still needs to be maintained. And there are certain foods that maintain the immune system. The first one is magnesium. Magnesium modulates the immune system and decreases the cytokines so that you're not getting that storm. Whole grains that we eat in macrobiotics, nuts and other vegetables are very rich in magnesium. Vitamin B3 inhibits pro-inflammatory cytokines as well. So that's the best source of that is beans that we get in, chickpeas or zucchini beans and so forth. The other thing is vitamin D. Vitamin D is very important in modulating the immune system and in calcium metabolism. And calcium is an alkaline mineral that we need in our body. You may have read reports that certain groups of people are not being affected very much at all by this coronavirus. One group of such people is the Aborigines in Australia. They have very few cases there, if any at all. Another group of people that you would think would be very immune deficient is the homeless population throughout the Western world. But these people are outside all the time, or most of their lives. They're getting massive doses of vitamin D just because they're being out in the sunshine. So their immune system is functioning and they're not having experience in these viruses to the way other people are. Vitamin A. Vitamin A forms a keratin barrier around your cells, which prevents the viruses from getting in. And of course, vitamin A can be a source of any orange, yellow, or purple vegetable is a really good source for that. Of course, we can get too much of that. There's such a thing as vitamin A poisoning, but a good solid amount of vitamin A from those yellow vegetables or orange vegetables is good. Vitamin C is a free radical remover. Of course, fruits contain vitamin C, but also greens, any kind of green leafy vegetable is full of vitamin C. And it is necessary when you're cooking vitamin greens that you don't boil them for more than 3 minutes. If you do the vitamin C, so make sure that when you like in our soup, other ways of cooking vitamin greens, we want to make sure that we don't cook them for more than 3 minutes. So, just put them in at the end if you're cooking them with other things, and don't let them boil for more than 3 minutes. Iodine. Iodine attaches to omega-3 and around your cells and wards off microbes. Iodine, of course, is very deficient in the modern world because what they did was they took sea salt and removed all of the trace minerals from it. Years ago, people started developing goiters with their from the thyroid. Okay, very good. Yeah, so zinc destroys the viral membrane, but unfortunately, zinc does not enter the cell when the virus is outside the cell. So that's a very important thing to do. Antioxidants, whole grains, beans, and nuts, by the way, are valid forms of grains, of zinc. Any antioxidant is basically just a food that is alkaline forming. Vegetables, miso, tamari, even fruits, but fruits are alkaline forming only at the end. They're temporary, what I call temporarily acid forming, because the sugar in the fruits is absorbed through our mouth immediately, and it creates an acidic environment in our blood and intercellular fluid temporarily. Then once the pulp of the fruit is digested and metabolized, then the net result is alkaline. But that's why we want to limit fruits to not too much fruits, because they are temporarily acidic forming and would not be communicable, for communicable diseases. And then the last thing for immune construction would be iron. Sea vegetables is a great source of iron, especially nori and things like that. Iron is necessary for the transportation of oxygen in the body, and that's creating an alkaline condition as well. So all of those things, we can talk about them and we think about them, but just eating a standard macrobiotic diet, we're going to get all of those things. We don't really have to focus on, did I get my iron today? Did I get my zinc today? And all that kind of thing. But what we do have to focus on is the immune system destroyers. It's really not so much, even if you're eating a standard American diet, you're probably getting most of those nutrients, with the possible exception of the iodine. But certain foods destroy the immune system and make it so that those foods that we're taking in, those nutrients that do build the immune system, are not able to function in their normal capacity. The most important of those is sugar. Sugar is acid forming, and it actually nourishes any microbes. They are, if I were a microbe, sugar would be the food that I would want more than anything else. Too much oil, especially olive oil, which I think may be one of the reasons why the mortality rate in Italy was so high, was because Italy uses so much olive oil in their diet. And animal fat makes the body susceptible to bacterial growth more so than the virus growth. But that bacterial growth uses up immune resources, and therefore makes your body more susceptible to viruses, because the resources are being used to fight the bacteria. And then any acid forming food, which is basically any food that is not a vegetable or a fruit. Certain grains are alkaline forming, like millet and amaranth, but even brown rice, which is a staple from macrobiotics, is acid forming just in its normal form. So it's very important for when we consume when we consume brown rice, to make sure we add proper amount of sea salt to it. We use gamascio to alkalize it when we consume it. And then, of course, the most important thing, I'm sure most of you all know this already, is to chew it, because the saliva, when we chew it thoroughly, the saliva that we have in a mixture with that grain or rice alkalizes it and negates the acidic effect of it. So those are the things that we need to do. And I think at this point, if there's any questions, I would save 5-10 minutes for that. But that's the issue of it. We really don't have to worry about viruses as long as we have a functioning immune system. And I don't know if I mentioned it or not before, but the best way to make sure that your thymus is functioning still as much as it can is cruciferous vegetables. Cabbages, broccoli, cauliflower, those types of vegetables, very stimulating, very nourishing for the thymus, which is very important for being exposed to any kind of virus that we have not experienced yet in our lives. So, any questions at this point?
We have one person asking if you have some written sources to help us understand what you are saying. And then another question about any kind of understanding of how this virus, the coronavirus, is going to play out in the world. I mean, what's going to finally we'll all be able to develop immunity, or what you see kind of how it will develop?
Yeah, probably the one of the best written sources is a book written by Muramoto. It's called Natural Immunity. It was actually in response to the AIDS epidemic. But he applies what the principles that he talks about in there are applied to all viruses. Natural Immunity by Muramoto is the sort of the Bible of written virus, written infectious control. As far as playing out, of course, throughout the world, there's nothing different about the coronavirus, that the novel coronavirus, than from any other viruses that we've experienced. The only thing about it is that it's new. Because it's new, no one had a natural immunity to it already built up. So everyone became a vector to it, or a potential transference for it, and that's the only thing. But of course, you've heard reports that many people have tested positive for the virus, but are asymptomatic. They don't have any symptoms at all. And that is because their immune system did its job and functioned properly. But even so, they become no longer a vector. And so there's it's not a bell-shaped curve, but it's I've forgotten the exact name of it, but it's sort of looks like the Rock of Gibraltar, which goes up straight and then kind of tapers off to the right. That's what it looks like in every case that you can imagine, in every situation. So every virus is like that. Every location is like that. And it doesn't matter if they've been on lockdown or not, or social distancing or not. The graph looks the same in every location. So it's just a matter of time. And of course, if you do, certain things, then like social distancing like that, then you do inhibit the initial growth, but that just means that the lengthen the time the graph has to go down to the bottom. So yes, there is such a thing as herd immunity. It will eventually play out, and that's the only thing that's going to make it play out. But on an individual basis, the thing to do is to just protect yourself by having a strong immune system. The fact is, unless you live your rest of your life in a plastic bubble, you're going to be exposed to the virus. And your only defense against it will be the condition of your own immune system. Yeah. Any other?
Someone is asking about the issue with olive oil. You mentioned in Italy. Yeah.
Yeah. In macrobiotics, we do use oil, but we use it sparingly, depending on the condition of the person. And we use selectively in types of oil. Sesame oil is a preferred oil. Certain oils we don't want to use at all, like canola oil or the other oils that we might use sometimes are corn oil or safflower oil. But we want to use sesame oil more than any other oil. Olive oil is very rich, that's why it's used so often. It's very delicious, but it's more acid forming than the other oils. So I'm not saying never to use it. I use it in salads occasionally, but you don't want to use it on a heavy dose of it on a regular basis. Just, moderation. And of course, if you did develop symptoms of a virus or an infection, then you'd want to avoid it completely until that situation passed. Yes.
Asking if there's another oil besides sesame that you could recommend. A lighter oil.
Safflower oil is one that's used sometimes, but for sautéing or something like that, I would stick with the sesame oil.
Yeah. Mm-hmm. So isolation, are we just prolonging the time until we all become immune to the virus through isolation?
Yes,
Does that make sense?
yes,
Okay.
that's correct. We're just prolonging the time. You know, as I said at the beginning, viruses are necessary for human evolution, for human diversity. What actually happens is we come in contact with the virus enters our body, it enters our cells and uses our cells, our DNA to reproduce. And then we shed that virus and it may be picked up by someone else. So that person's DNA, our DNA is actually through the virus going into another person. And that is the way that of course, this happens over, millennia, but that is the way that human diversity occurs. Otherwise, we'd all be the same person. The idea that, human distancing from ourselves is going to somehow save us is a bad idea. Not to mention the fact that, just psychologically, human contact is very important. Um, Being able to see facial expressions of persons, whether they're smiling or frowning, human touch, just shaking someone's hand or hugging someone, those types of things, make us more human and less fearful of other people. It creates a bond between people of different societies and different cultures. And if you don't have that, if you, for some reason, you think that this person if you walk into a store and you see someone across the aisle and you think of that person as a threat to you, then this just creates fear and division among people. So, if you have a strong immune system and understand how your immune system works, then you don't have that fear and you don't worry about it.
That's right.
I can't hear you. For some reason, I can't hear you.
There you go. I'm lauding and applauding you because you've done a wonderful job of really explaining something very easy to understand. You've done a wonderful job. We really appreciate you. This has been really important and pleasant because it's been so easy to follow you. We really appreciate that.
Very good.
Well
I'm
done.
sorry for the connection problems there.
Yeah. Well, thank you very much. It's really a pleasure.
Great. Nice meeting everyone. And like I said, if you want to contact me, it's gregsamples.com. There's a way on there that you can do that. And
Is there time for another question?
yes.
Sure.
Well, as far as I'm concerned, yes.
How can you know how strong your immune system is, or the opposite, how weak it might be? How do you know? Was I heard?
It's a really good question. With other, yeah. Can you hear me? If you're familiar with something called Oriental diagnosis, it's not much different from that. If a person has skin problems, that's an indication that their immune system is not functioning well. If you have pimples, the other thing is if you have winter cold, if you have a cold, that's not unusual. If you have colds in the summertime, that's an indication that your immune system is not functioning very well. If you have chronic skin problems such as eczema or something like that, or just those are indications that your immune system is not functioning well. And then the biggest thing though is that if you get any kind of infection, whether it's influenza or the coronavirus or just a stomach virus or something like that, or strep throat or something like that, if you require antibiotics to get over that, that means your immune system is very, very deficient. You know, your body should be able to handle that without any problem at all. But if it can't, if you really have to have antibiotics to get over it, that means your immune system is really under attack or malfunctioning, and you really need to get on it with, you know, eliminating the foods that we talked about earlier.
I have a question.
Yes.
If you can answer this, why do you think, in your opinion, that Italy has such a low rate the second time around now? And why do you think that Israel has such a high rate the second time around of infections after the first round was so low?
Okay, so I'll ask the Italy question. I'll ask for answer first. There are certain countries that, if you look at the graph of what we call total death, you know, total mortality rates. Okay, so in 2019, some countries had a lower than normal mortality rate for that year. And so in those countries, when the coronavirus hit, they had the higher mortality rates than other countries. You might say it's sort of like this was just dry kindling that was sitting there. You know, people who there was an abnormal number of people who were might have died the previous year that didn't die that year because there was not a virus or something. And so when this one came along, it was like, you know, just like a forest that didn't have any rain in it. It was just a tinderbox that happened when they hit that. But then the other countries that had normal mortality rates or higher mortality rates the previous year, they did not experience those high mortality rates. I don't know if that's the case for Israel or not, but I know it is for Italy. That was the situation in Italy. So, but I would suspect that probably something like that as well in Israel, that maybe they had a normal or a higher mortality rate the previous year, so they didn't have as many people who were as susceptible at the first go around. Now, as to why the second one is higher, you know, I'm not sure I would understand. I probably would need some more information about that before I can answer that question.
Okay, thanks.
If that helps.
Okay, so great, thanks, Greg. Really, we appreciate it very much. You've done a masterful job.
My pleasure.
And we have 5 minutes for a break, 4 minutes at this point. And Joe, welcome. I see you there. And we'll begin at the top of the hour. So everyone, if you would like to take a break. And again, Greg, our thanks.